Okay, so for the last few days and over the last few videos, I've been hinting at the fact that we have a fairly large project that we've been working on, but I've yet to unveil it. Well, today's the day that we're going to start filming this and work you through the tutorial of how to set it up. So I've been working on a Docker-hosted desktop as a service installation using a program and a whole back server structure called Kasm, which has an open source element to it and is free for most of us as long as we stay inside of their guideline. Now, at the moment of filming this section, I haven't fully tested some of the features on it, but I've used enough that I feel confident to start filming the video and bringing you the installation and setup procedure for this. For somebody like me that likes to work mobilely and have most of our equipment on a server, this really offers a lot of lifestyle improvement for us. And for somebody that likes to have sandboxed environments that basically destroy themselves after they're done using them, this is also great. But I'd like to point you in another direction as well. Many times I see comments, I see videos and other things asking us about how to get a VDI style setup on Proxmox, and this would be great. So in the conclusion of this video, I'm going to show you how to set a Raspberry Pi up as a thin client, and I'm not doing it, and the reason I put it in quotes is I'm not necessarily going to fully strip out Raspberry. Instead, I'm going to use Raspberry and I'm going to build upon it so it automatically brings you to a Kasm login page and allows you to set up, and it keeps you in a Kasm environment the whole time. And that's really quite straightforward. But before we get to the installation, let's take a look at Kasm fully up and running so you can see what it looks like. All right, so here's Kasm inside of my web browser, and that's right, we're running entirely inside of a web browser here. So we can go ahead and we can log into Kasm, and we're presented with many different things. And there's actually more than this. As you can see, I have an asterisk here, and I'm still having a little bit of problems with Steam, but I've been able to get a few of these to work and enough of these to work that I feel like it's definitely worth making this video. So we have Atom, and we even have like an Ubuntu desktop, and we have our numerous browsers. We talked about Kasm in a previous video and some of these browsers where we self-hosted an individual container inside of Docker using a Proxmox container in order to build a web browsing testing environment for our web development work. But you can even host Zoom, Team, Kali Linux, Ubuntu, and some of your favorite text editors for doing development work inside of Kasm as well. For this video, we're going to take a look at Atom because, as you guys all well know, it's one of my favorite text editors. So inside of this video, let's first take a look at Ubuntu desktop, as I feel that may be a great place where we want to start doing some of our stuff here in our normal everyday work environment. So the first thing it's going to do is ask us to allow it to send text and copy with their clipboard with our system. I'm going to allow that. It does make things a lot easier when we're working inside of the Kasm system and with our home system. Now, this might not be the best total idea with the Raspberry Pi, but here we're on my Mac and we're doing this inside of everything. So we're going to allow it. Now, as I give you a tour, we have Sublime text editor that's pre-installed and able to be worked with. We also have Office software, Nextcloud compatibility, because after all, this does destroy itself, so any files or anything we save will be destroyed. Now, there's some workarounds, and I'll show you with persistent storage and some of the other things, so we can save our files and have something to come back to at the end. And we have numerous different web browsers and Virtual Studio and Zoom, even a screen recorder pre-built in. Now, OBS is quite system intensive, and I'm not going to try it now because I don't think the experience would be great with the amount of resources I had. But if you had a graphics card and some of the other resources to support this, this might be a great idea. That's another thing I want to note is this right now is running inside of a Proxmox VM with no graphics card. So this experience is basically as bare bones as it can get, and you can improve upon it from here. And I definitely look forward to doing some of that improvement as maybe we move into our R710 as we get back to the Freedom House and are able to do this. I actually think I'm going to set up an instance when we get there and pass through a GPU to it because it's something that I think I'm going to use in my personal life to allow me to be more flexible. So the other thing I want to show you is I want to actually open Firefox because quite often I'm doing web browsing and maybe I'm stumbling into places that I don't necessarily always feel the most comfortable to do some research, and it's always nice to have a sandboxed environment. And now I probably wouldn't do this here, but let's head over to YouTube, give a search for my channel. Well, good morning, good afternoon, whatever this is with you watching it. I've been working on a pretty fun little project here with Kasm that I'm getting ready to bring to you guys pretty soon. So as you can see, we're even able to have audio working now that we're inside of the Kasm space, and we still have the same performance that we had back when we were doing this inside of Docker, where we get really good video streaming and we're able to get decent response time with pages loaded and everything else. So now let's move on to the installation and how I got this all running inside of Proxmox, and I'll show you how to get it set up, get your persistent storage set up, and how we're going to even link Nextcloud in and some of the other features so that you can start using Kasm to do the work you want. Then I'm going to finish off by showing you how to set up the Raspberry Pi thin client that you're able to then use and host remotely for your project. Maybe you want a system for your kids to use that necessarily can't be screwed up, or another member of your family that historically gets viruses and messes up the computer, and it's nice to just have a system for them that restores to default and you set their settings, and that's that. So with that, let's move on to the installation. Okay, so the first part of this installation, we're going to need a VM to do this on. I've tried multiple times to do this on a container or in a container or LXC container in Proxmox, and I just can't seem to get it to run right. So we're going to have to do this in a VM today, and that's fine, but I want to walk you through the steps. I haven't done it in a long time of installing Debian, and we're choosing Debian today over Ubuntu for a few different reasons. Got to do with the new installation process of Ubuntu. I didn't dig into it too much, but when I went to install Ubuntu not through a cloud init image, which is a lot of command line work that I don't like demonstrating more or less because I feel people don't enjoy it. I was losing over half of my drive space for some reason to just free space, and I tried for a little while to play with settings and see if I could adjust that, and I wasn't successful. So I don't know what I was doing wrong, but we're going to do this here on Debian. I think Debian's a better choice anyways. It's quite a bit lighter of weight and a little bit more open source and a little bit less controlled by one entity, if that makes sense. So I guess I'm starting that process that a lot of other Linux people do, where they move away from Ubuntu and Canautilus for numerous reasons, and I guess it's just starting for me. Anyways, enough with that. That's a different discussion, and if you want to hear my opinions, you can drop the comments and we'll talk about it in a vlog session one day. But so we're going to go up here to the top of our web interface here in Proxmox, and we're going to click Create VM. And this is how we're going to start setting up a VM. So we're going to give it a name, and we're just going to call it what it is. And I don't necessarily want mine to start on boot, so we'll leave that unchecked. For OS, again, I said Debian. Well, I have Debian's image down here, but maybe we want to go off and show you how to get the image. So we can go just do a search for Debian. And Debian's a little bit different than Ubuntu in the fact that Debian has one image for both their desktop install and their server install. And that's kind of nice as far as our Proxmox goes because we don't have to have multiple things. So right here we see a Debian 11.6, and I'm just going to right click on it and copy link address. Now we'll go to Proxmox and we're going to go to local. We're going to go to ISO images and we're going to go download from URL. I'm going to paste this URL in here and hit query URL. And that's going to give us the image. At the end here, I'm going to put dash video so you guys can see that this image downloaded here. And now we're going to take note that it's SHA 512 sum. We're going to click on that, and since it's this image that we're installing right here, we're going to double click this and we're going to copy it. Now going back to our Proxmox interface, yours might look something like this. We're going to hit advanced and we're going to hit hash, select 512 and paste it in the hash. Now we can hit download and it's going to download our image. And our image was all verified and we're ready to use it here. So you can see that our image showed up here again. And it's not best practices to really have two of identical images on your system, but you know, for video purposes. So we'll go back up and hit create VM now, and we'll start the process of setting up our Kasm server. So I'm going to type Kasm server for a name. You can call yours as you want. For OS, we're going to go ahead, select that image that we just downloaded. You can notice it's got VE video at the end of it. For system, I'm going to go ahead and check QEMU guest agent. That's going to allow Proxmox and the VM to communicate with each other here eventually after we install some software. Everything else can be left vault. Now we're going to use a SCSI drive and we're going to store it on local LVM. But Kasm's going to need at least 100 gig drive to work off of. And I'm going to set mine just over it at 110. And they also suggest that you have an SSD. I do happen to have an SSD in this drive, in this system. So you want to make sure you go ahead and check discard. That helps set all the trim settings so you're not adding unneeded wear and tear to your SSD. All right, so we'll hit next. So Kasm wants to have at least 2 CPUs. I only have 4 in this system, so I'm going to go ahead and select 3. Now, I've been told by viewer comments, and I haven't been a great person and gone off and researched whether they're correct or not, but I am going to tell you what they say. They say that I need to have them in parallel because it causes strange things to happen inside the system. I've never experienced any of these, and even on the video where the commenter commented, he didn't point out any of those, and we didn't seem to experience anything. So I'm setting mine to 3, but be wary that there may be best practices or information out there that tells you not to use 3 cores. So with that, we're going to hit next, and you need to have at least 2 gigs of RAM for Kasm to run, but it's suggested to have more. And you're going to see as part of this process that we're actually going to end up even making like a multi-gig swap. Kasm needs a lot of resources. Now think about what it's doing and how it's doing it, and that should be pretty understandable for it. And anyways, so I'm just going to click this pointer so we get up above 4,000. So we have somewhere over 4 gigs here. Network, I am going to leave mine this time. Maybe I won't. I'm actually going to put it on the VLAN. We've talked about this. This is something that necessarily you may not have to do, but I do want to explain it. The way my network's set up, I have segregated traffic from my Proxmox server, my IoT devices, my personal computers, my VMs, my containers, and so on. So my network settings have a VLAN attached to this bridge. So even though we use one Ethernet port, the router sees them as 2 different ports and separates the traffic. So then we'll hit next and we're going to hit finished. So if you're wondering a little bit more about that network bridge, let's go up here to our server. Real quick, all this is being created, and under system, you can see this is VMBR. And if you look here under ports and services, it's VLAN 60. Now VLAN 60 here, if we were to edit it, is attached to the ENO1 port, which is the same port that VMBR 0 is. So it's basically using the same Ethernet port, but it's attaching a VLAN 60 tag to it, and it's creating a separate bridge. This is where my VMs and stuff work, and my firewall rules are set up differently than my firewall rules for VMBR 0. I may have been able to configure that a little bit differently, where my Proxmox communicated over a VLAN or a port itself, and I had a single bridge, but this is how I configured it for this particular setup. So anyways, now our Kasm server image has been created right here at 116, and we can go ahead and press start and click console. Now at this point in time, we've clicked all the necessary options that we have, and we don't need to do anything more here. Even once we install the guest agent, we've already selected it. It's ready to go. It's just not able to communicate with our Proxmox system yet. So you notice that this starts up with a graphical installer. We're going to press the down arrow and select the standard installer. So to my knowledge, the graphical installer doesn't allow us to disable the desktop and install the server version of Debian. So anyways, now we're here at English. So we'll hit enter. We are in the United States. We want American English. Host name, we're going to call this Kasm today. So we'll enter Kasm, hit enter. Domain name, we're going to give it Kasm again, enter. We're going to set our root password. You want to make sure this is something strong. This is your password rights over the entire system. So for us, I'll make up a password. It asks you to confirm the password. Now it's going to ask you for the full name of the user. We're going to give it VE. We're going to call it the username VE. And now we need to set up a password for VE. Best practices say to have a different password for your root user to your primary user. We're in the Eastern time zone, so I'm pressing enter. I want the guided entire disk. I want this disk, one, all files in one partition, and we're going to finish partitioning and write disk. We're going to select yes to write changes. So apparently my HOA is doing some lawn fertilizing, so I apologize for the motor running in the background. There's not much I can do about it. Hopefully you can't hear. We do not need to scan for any extra installation media, so I'm just going to select no. We want to use the United States mirror. This is fine. We're using no proxy. We do not want to participate in any surveys, so we're going to select no again. And the default's no, which is really nice. So this is the point, since we don't want a desktop on Debian, that we need to pay attention to. So we want to uncheck Debian desktop environment and the browser. If you don't uncheck both of them, what's going to happen is you're still going to get a desktop. Kind of unfortunate, but that's what it is. Now we also want to check SSH server, and we're going to leave standard system utilities checked, and we're going to press enter now. So the grub bootloader is the bootloader that Linux uses traditionally for starting up an operating system, so we definitely want to install that. So we're going to press enter. We're going to need to tab down to select the drive to put it on. By default, they have you enter your device manually. The device does show up in the screen, so we just hit the down key and then we can hit enter. Now I've gotten caught a couple of times installing Debian where I'm kind of used to Ubuntu's and I'm not looking to really pay attention and just get an operating system quickly, and I click that manual and kind of hit enter going through it and forget to hit that down key. And that has caused problems. So if you get into a point where you've installed Debian but it's not booting or something, go back through and make sure you pay attention at that screen. Quite commonly, that's my mistake I made. So the installation is complete and it looks like we want to restart. So we're going to hit enter, and we're able to hit enter here, and the boot up will start. So let me go ahead. Hopefully we don't get behind my picture now, but this should make it a little bit bigger so you can see what's going on. We need to log in. Of course, we set up our username as VE, but I actually want to log in for the first time as root. So with Debian, sudo is not installed as default, and I don't know if there's something else on here that you're supposed to use over sudo to get sudo user permissions or super user permissions for the rest of the system. But I traditionally just install sudo at this point, and we'll be getting there here in a minute. The first thing I always do is run an apt update, and you notice there's no sudo here because I'm actually in as root, and I always string them together. Grade-y, and Debian's much better than Ubuntu with the way their releases work. Their releases, changing my note. Their releases are continuously rolling, so you tend to get the most up-to-date software even when you do your installations. Really nice and something I enjoy very much about Debian. So now we're going to run an apt install, and we're going to install QEMU-guest-agent. And apparently this evening and it looks like QEMU guest agent is installed by default now. That's awesome. I'm so glad to see that. So the last thing I need to do is install sudo. And now that we have sudo installed, we need to give VE or our user permission to use sudo. So we're going to do a user mod -a-big G, our username, and sudo. Or it's actually group, which is sudo, and our user. So now if we did it, well, we need to be in the new account. All right, so we can exit and we can log in with VE, and we can do an ID, and we make sure we have sudo, which we do indeed have sudo. So then I usually close out my root account by doing a sudo passwd-l, and so this will get rid of our password and make it impossible to log into root. So, it eliminates our chances of having a security breach there with root. So I'm going to go ahead and I'll be back in a few seconds. We're going to set up an SSH connection and start the installation process of our of Kasm. First thing we want to do though is run sudo shutdown, shut the system down, which will happen in just a minute here. So here you can see our Proxmox web interface has now updated and it's turned off. Everything looks normal. We can go ahead, press start, and this time when our system comes online, we'll know because the IP address here for guest agent is going to change and it's going to appear. And that's going to give us the information we need to establish our SSH connection, hopefully if all the software is installed correctly, and we'll be able to start our installation process of Kasm. So now that we know our address of our server, I'm going to open terminal window, and I have a very special one that I've made here for you guys. So let me get it open. We'll move this out of the way. We're going to take note 192.168.14. And we're going to enter SSH VE at 192.168.14. I'm on a Mac. It's going to ask me if I'm accepting the fingerprint. Yes. And the password because I don't have SSH keys set up. So now we're in. I always like just to run a sudo apt-update to make sure everything's up to date, even though we know it is. It's kind of just a habit of mine at this point, even though just seconds before we went ahead and downloaded all the updates and did the installation. So that I'll be all right. So we've established our SSH connection. Got Debian all set up and ready to go, and we're ready to start installing Kasm here on this Debian server. So the first thing we're going to need to do is create our swap partition, which is going to be needed because Kasm requires a lot of swap space, and it's suggested to have a minimum of 1 gig per user. So the first command is sudo fallocate-l, and we're going to allocate 4 gigs, and we're going to give it a 4 gig.swap path. Now we need to set permissions to 600 for that file. We need to now turn that file into a swap file with mkswap, and the last thing we need to do is set it so it mounts automatically when we reboot the system. We're going to do that with that command for spawn it. That gets it going, up and running. We could verify it exists. Let's go ahead and do that, and we can do that with cat, and you can see that it does indeed exist. Now we're going to use echo, and we're going to set its presence in fstab. So now we've created our swap file, and we're ready to do the Kasm install. Now I'm going to be piecing together some commands from two sets of Kasm literature, because the Kasm install literature has us installing version 1.12, and there's actually now version 1.3 out. So bear with me as I piece together some of these commands. So the first thing we're going to need to do is enter our temp directory, and we're going to go ahead and hopefully download the files we need for version 1.13. And we're going to use Carl to do that. And it says Carl isn't found. So let's go ahead and do a sudo apt install Carl. And now we can try using Carl again. All right, so we got our files downloaded. Now we need to unpack our tar. And at this point, I'm going to run an ls so I can see the files. So it is called Kasm release. So I'm going to use the command sudo bash kasm _release / install.sh to execute the install script. Now this install script takes a long time, and I'm probably going to cut this up so that you can kind of see what it looks like and fast forward it, but it doesn't waste a whole lot of. We're going to press Y for yes. You want to go ahead and read this user agreement. I've already read it a few times, so I'm just answering yes. And I'll be back when we're done installing Kasm to show you how to log in and show you more about Kasm. Okay, so Kasm's done installing. Now, if you see, we get a whole printout of the default Kasm passwords and stuff. We're going to want to go ahead and copy these and put them someplace safe for later, and remember a few of them for ourselves here in a minute. So I'm just going to make a file here. So I'm just going to make a file here inside of Atom, and I'm going to paste them down. And I'm going to move this down to my other screen so I have it here for the next steps, but know it exists and know where that information is coming from. All right, so at our web browser, again, we're going to take note of our IP address, and we're going to use HTTPS very similarly to how we log into our Proxmox server. And notice I'm putting no colon at the end of. We get the same warning screen about the privately signed certificate that we do with Proxmox. We're just going to hit advance and proceed, just like we do Proxmox. And here we are at the Kasm login screen. So the first thing we're going to want to do is log into Kasm. Now, default admin username is admin@kasm.local, and the default password was given to us in that printout screen. So go ahead and copy and paste yours in, and we're going to log in. Now, the first thing I'm going to do is head for users, and the admin user, I am going to hit these three dots here, and I'm going to hit edit. Now, I just want to check things out, and I can hit submit here, and then I'm going to hit reset password, and it'll ask me for a new password, and hit submit. So now I have a password that I can use. Now I can choose at this point to delete this user or change its password or change other information about it. So I can go ahead and change my username here for this user. Let's call it VE, and we're going to submit that. Now we'll do the same process of resetting the password. So going back to some of the early days with Raspberry Pis, we really learned there, and it was known prior, but as a whole, as a country, as a world, and even a profession, or even us hobbyists, we learned about Raspberry Pis and the fact that known username, even though they're not root account, with known passwords, or even changing passwords, but just having known username, really presents a usability risk for us as far as security, and we want to change them whenever possible. So I went ahead and did that. I'm going to keep this one the same here for today just to leave it alone, but I believe we are able to change it. So now that we have Kasm set up, let's jump over, and I think I showed you at the beginning of this a little bit about Kasm, and at that point in that video we were using Kasm 1.12, not Kasm 1.13. So let's check out just what it looks like. So from the admin terminal we can actually check out Workspaces, and Kasm 113 looks like it doesn't have any workspaces. Interesting. So that's new. All right, let's head back to admin and remedy that. So we have workspaces here. We can add workspaces. We can add a container, and oh, nice. We're not going to have to do that. So we'll select container here from registry. We're going to be able to scroll down and pick Firefox, and it's going to automatically fill everything out for us minus the persistent storage. Now, for my web browsers, I don't particularly like to set up persistent storage. So let's first set this one up and get it downloading. And if we come over to Workspaces, you'll notice there's a little icon here. This image needs to be downloaded, and it'll take a little bit of time. So go back to Workspaces. We're going to add workspace. We're going to select from container, and from our registry, let's go ahead and find Ubuntu desktop. And I think Focal's a good one to have, so we can set everything up. Notice that we did not pass through a GPU, but you can actually have a GPU and you can inherit or share this. But here for this one, we're actually going to select a persistent drive. And I'm going to store mine at home/Ubuntu Focal/curly brace username. Now this curly brace is a variable. So for the user admin and the user VE, we're actually going to have separate folders for the persistent storage. We're going to leave everything out. Now we're also going to have to do one more step to turn on that persistent storage. So we're going to go up here to groups. We're going to select administrator for this, and we're going to hit U. Under user groups, or actually under group settings, we hit add setting, and then I'm going to start typing allow underscore and start typing persistent, and we can set persistent profile, and we set it to true, and we hit add. Now, because we don't want it just for administrator, but we want it for all users, so to create a second group, we're going to hit groups, add group, name of group, we'll call ours user, we'll give it a priority, let's give it 3, submit, view, and group settings, group workspaces, group settings, persistent profile, set it true, add, and we need to add our, there we have it, all up, right? So let's go over to Workspaces. We can see Firefox, and this should be Ubuntu Focal. So let's go ahead and hit Ubuntu. You notice that we get persistent storage. We want that enabled, and we're going to launch the session. And here we have our Ubuntu desktop with our text editor and our web browser installed. We want to allow this, and we can check out to see if there's any other things installed, and it doesn't look like there is this time. Let's go ahead and open Sublime. We're going to just go ahead and save a file, and we're going to save it on desktop and save it. Now let's go ahead, session, delete, and open the session up. And notice our file stays right there and created. So we're able to have storage, store some stuff about the users, make sure we have all of that stored and backed up so users can keep track of things. Now, necessarily, if I want to, like a sandbox web browser or something, that's not necessarily the best choice. But for a desktop where I want people doing text editing, video editing, and so on and so forth, that's a great way to have it. All right, so that has taken you through installing and setting up Kasm and how to get using it in your web browser. So next up, we're going to set up a Raspberry Pi and start using that Raspberry Pi with Kasm as a quote-unquote thin client. Now, the Raspberry Pi setup that I've developed doesn't necessarily totally qualify as a thin client. It is sitting on top of a full operating system. It is sitting on top of Raspberry. But it's definitely a lightweight system connecting to a server where the operating system and all of the components are hosted on the server. So I'm calling it a quote thin client. All right, we'll be back in a few seconds, your time, with how to start that setup. All right, so we're going to start making the creation of the Raspberry Pi thin client here. And you notice I'm at the Raspberry Pi site already for you. And that's because we're going to use the Raspberry Pi imager our tool to start downloading and prepping the software and getting it ready. So to do that, we're going to click on software and we're going to download the imager tool here. I already have mine already up and going and installed. So let's jump over here and look at what that looks like. And the first thing we're going to want to do is choose the storage device. I already have a card in mine and ready to go. So then we're going to click choose OS and I'm going to click Raspberry Pi other OS. So I'm using a cheaper Raspberry Pi 3B today, but that still has 64-bit capability. So I do need the desktop and all of the other components that go along with the desktop. So I'm going to choose Raspberry Pi OS 64 and not the light version. Now, at this point, I can go ahead and click right, but I can also click on this gear cog thing right here in the lower right-hand side of the screen. And I blew this up for you, so I apologize that you can't see where my mouse is. But hopefully you can kind of see the color response change in the lower right-hand corner for the gear cog for the settings. And on a Mac, I'm going to have to give it permission if I want it to use my wireless password and stuff for default. I'm not going to do that. So the first thing I'm going to do here is set my host name, and I'll call it a Kasm client. We can set our SSH. And I want to set up my Wi-Fi so I can use that. I need to change my country code. Now, the way they've set this up a little bit is rather annoying. I have to scroll all the way down to the US. And I think they could have done a lot better here to set this up correctly. But I understand they're developing stuff too. So there's US. We can set my time zone as coast. And then we can hit save. And now we can hit right and hit yes. On a Mac, we're going to have to give it our system password. And now it'll start writing the image here. And I'll be back when it's done creating the image to show you the next few steps that we're going to need to follow. But it's really nice now. In the early days, we weren't able to do that we can configure that Raspberry Pi headless almost exactly like we did. So anyways, I'll be back in a few seconds your time to show you how to do the next steps for setting up this thin client. All right, so yesterday when we filmed this section of the video, for some reason we lost audio. So I'm going to show you what we did yesterday to get this all set up. And we're using SSH here today just because I don't have a great way of screen capturing the output of the Raspberry Pi. As you'll see in a minute, I'm actually going to use a webcam, or my phone camera rather, to do all of that recording. But so let's get with this. And we've logged into my router, which if you've watched some of my other videos is an ER605 from TP-Link. And we've gotten the IP address of the Raspberry Pi, which you saw a second ago we set up as Kasm client. So it's right here as number 1. And we're going to go SSH. Actually, I probably have it if I press the up arrow, and I do. And so we can log in. So we just need to give it our password, if I can remember my password from yesterday. All right, so now that we're logged in, I always run an apt update, and I needed to run sudo in front of that because we're, of course, not in root. And everything's up to date, most likely because we did it yesterday. Anyways, the next thing we usually do, or the next thing we need to do to begin creating this thin client, is make sure chromium-browser is installed. And we did that with the command sudo apt install chromium-browser. Now, we found out yesterday that chromium-browser is indeed installed as default part of Raspberry and desktop. And like I said yesterday and during the installation video and multiple times, I haven't stripped out a lot of the stuff on this. I probably should have spent some time and made a custom image so it could be a true thin client, but we basically built on top of an operating system that was already extremely lightweight and meant for a Raspberry Pi, and we've just added commands here, or will be adding commands here, to make it so that it automatically loads a web browser and automatically sets up to Kasm, just like a thin client would. So the next command is the command that we're actually going to do most of of that configuration is. So we're going to load nano text editor with sudo nano, and we're going to go to a file that's etc xdg lxsession LXDE-pi autostart, and this is a configuration file. Now, as default, these top 3 files here, or top 3 lines, are what run on the Raspberry Pi. We're going to add this at chromium-browser -- kiosk mode, which kiosk mode gets rid of all the browser bars and everything else. So it basically full screens the Raspberry Pi's web browser, so it is a thin client, right? We're in Kasm and we're going to use Kasm, and that's what we're going to do with it. And then we're going to disable restore session because we don't want to restore the session state after it shuts down. And then we're targeting the Kasm server. So https:// IP address to your Kasm server. Now, once that's done, we can press Ctrl+X, log out, and we're going to then run the command sudo shutdown. And the reason we're shutting down is we want to fully bring this thing to a state, and I want to set up my camera. So when I did the restart command, I found that I had problems and the web browser didn't activate. So we want to bring it all the way down to a shutdown and then bring it up again in order for that all to happen. All right, so in a second here, I'm of course going to set up my camera, or have set up my camera because we're now in the future. And I'm going to show you how to, or what it looks like for the Raspberry Pi thin client to log into Kasm and how to use Kasm. Okay, so I got the Raspberry Pi here set up on my desk and my monitor is plugged in. And this isn't going to be the best experience because I'm on an ultra wide. And so, I think it'll give you a good enough demonstration of everything working here with the Raspberry Pi. So what I'm doing right now is unplugging and plugging the Raspberry Pi back in so it starts its boot process. And I'm going to bring you up so you see my monitor, hopefully well enough that you can see the experience. And I apologize for being on my phone microphone. It's also the best audio that I have for this. I really need to get hardware for HDMI capture, but I don't have any at the present time. So here's our Raspberry Pi booting up. You'll notice we're achieving an internet connection, and we should load a web browser. There we go. And it's asked for the first time here if we want to log in, and of course we hit the advanced and to proceed. You could always set up a certificate authority or whatnot if you were doing this and you didn't want the users to have to check that option. And here we are, we've connected to Kasm. And all right, so we're going to enter the username of VE and the password that we set up in the installation process, in the configuration process, and we should be able to log into Kasm. Now, you can see I've added a couple more things. This was the Ubuntu desktop we used last time. I also added Kali. Let's check out Kali. And I've set up that persistent in the same way that we did for the Ubuntu desktop. And so here is Kali all set up and running on a thin client on a Raspberry Pi 3. I apologize again for my ultra wide. It doesn't present the best resolution here with a Raspberry Pi, but we are on a Raspberry Pi. And we can take a look at some of these different things. I don't really know, but you can see that we even have different exploits and stuff here inside of Kali. And as I scroll around, I'm hoping you're getting a good sense of the response rate that we're getting, even without a GPU. So with that, I'm going to conclude today's video. And now you know how to set up desktop as a service using Kasm and get a Raspberry Pi set up and working as a thin client using Kasm. As always, have a good night.